This lesson, no nonsense, no waffles, just the good stuff, circles and triangles. Well, welcome to Pure One, Chapter 6.5 about circles and triangles. This will be the last subchapter of the circle chapter. Okay, and also actually it will be the last lesson of this geometry lesson in the series of geometry, with chapter 4 about transformation of graph, chapter 5 about straight lines, and chapter 6 about circles. So, bit of quick recap. Angles in a semicircle is 90 degree. We know that based on circle theorem. And then the next 3 points, well, you have learned about distance and midpoint. Can ask you pause the video and write down the distance formula and the midpoint and the gradient learned from GCSE. Okay, when you're ready, press play. Right, so angle is a semi-triangle. When one of the length is the diameter, then the opposite will be a right angle. Distance formula, x2 minus x1 square plus y2 minus y1 square, square root, midpoint. Add up the x coordinates, half it. Add up the y coordinates, half it. Gradient, y2 minus y1 over x2 minus x1. So we're going to use all of these today in this lesson. Example, given the points P minus 2, 6, Q, 6, 0, and R, 5, 7, all line on a circle. Well, it's always P, Q, and R, isn't it? Or A, B, and C. We're kind of sick of them. Anyway, show that PR is perpendicular to QR. Well, you know that to show it's perpendicular, there's no better way to show than the gradient. So question A, want to find a gradient. So the gradient of PR, okay, so the MPR means gradient of PR equals y2 minus y1 over x2 minus x1. So put in the calculator, you get 1 over 7. And then you do the gradient of QR. So gradient of QR is 0 minus 6 over 6 minus 2, which is, am I right? QR. So I use the wrong coordinates. I'm just checking, see who is listening, obviously. I don't make mistakes, but you do. 0 minus 7, QR. So over 6 minus 5, which is negative 7. Because the gradient of PR times the gradient of QR, which is equals to 7, 1/7 times negative 7, which is minus 1. Therefore, PR is perpendicular. I use this symbol in here. It's a right angle when R means perpendicular to QR. Okay. Part B. Prove that PQ is diameter of a circle and hence work out the length of the diameter. So what we need to think about is, okay, so where did the circle come from? Right, let's have a look. So think about this. If we draw a circle out, okay, let's try to draw a circle. Okay. Let's try to draw a circle. Try, because you can never draw a perfect circle. Prove me wrong. You can never draw a perfect circle. Right. So if PQ, okay, so if PQ is diameter, that means like this, right? And then R will be here. We know it's a right angle, okay, because we've shown PR and RQ are perpendicular. So what we need to show is, so the actual proof is, okay, so if PQ is diameter, then surely then this will be a right angle because a right angle triangle. So therefore, what we need to show is because PR is perpendicular to QR, okay, therefore angle PRQ is 90 degree, and therefore PR is diameter. Because for this to be a right angle, then surely PQ has to be a diameter because circle theorem. Okay, right. So next part, we've proved PQ is diameter of circle. Hence, work out the length of diameter. To work out the length of diameter, so work out the length of PQ, we can use distance formula. Remember, the two straight bars here means the distance. So we can do -2 minus 6 squared plus 6 minus 0 squared, square root, equals, put in a calculator, equals 10. So therefore, the length of a circle, so the diameter, so that the diameter is 10. Okay. Part C, hence find the equation of circle. To find the equation of circle, we need x minus a squared plus y minus b squared equals r squared. We need two things, the center of circle, and also the radius. Okay, we know the diameter is 10, therefore the radius is half of 10, which is 5. So we know that. The question is, what's the center of circle? The center of circle is the midpoint of PQ. So what we need to do is to find the midpoint of PQ. So this is a very powerful tool to help you to brainstorm what you need to work out, what you need to do in maths. Okay. So midpoint of PQ. So the midpoint of PQ. So the midpoint of PQ equals. So let's work it out. So add up the x values, half it, add up the y values, half it, you get 2, 3. So therefore, the equation of circle is x minus 2 squared is the opposite sign of the center of circle. So x minus 2 squared plus y minus 3 squared equals the radius squared, 5 squared, which is 25. Right? Easy peasy. Right. Next one. Example again. Given the points P, Q, and R, I told you it's always P, Q, and R. We're fed up of them. So boring, P, Q, and R. Why can't they use something weird like G, H, and I? You know, given the points P, Q, and R lie all lie in a circle, again, circle, the equation of the perpendicular bisector of PQ is y equals 2x. Okay, find the perpendicular bisector of PR. So, well, the first thing we'll do is, if you would like to, you can draw a circle out just to try and see just visualize what's happening in here. Okay, so let me try draw a circle. Try draw a circle out. So in here, I know P is 316, so maybe 316 somewhere here. And then I've got 11, 12, maybe here. Minus 7, 6, maybe here. So I can sort of visualize circle be something like this. I know this is a perfect circle. I know I just mentioned there's no perfect circle in the earlier video, but I was wrong. This circle is perfect. So this point P is 316 and Q is 11, 12, and R maybe perhaps is here. Now, one thing to draw a circle is you notice the point 316, 16, if you look at the y coordinate, 16 is above 12 and above 6. Therefore, you can see the difference in high level in terms of the coordinates. Okay, so they're roughly in the same correct place. Right. What we want to find is PQ. So the equation of the perpendicular bisector of PQ is y equals 2x. So let's draw PQ. So PQ is here. Right? PQ is here. The perpendicular bisector means the line passed through the midpoint of PQ. This is the perpendicular bisector. So this is the perpendicular bisector. So PB. Okay, peanut butter. No, perpendicular bisector. Sorry. It's y equals 2x. So let's draw it y equals 2x. Find the equation of the perpendicular bisector of PR. So I want to find the perpendicular bisector of PR. So this is the PR. Perpendicular bisector means, yeah. Okay, so this is PB. Let's put PB of PQ. This is the perpendicular bisector of PR. Okay, want to find the equation out. So what we need to find out is, actually, I don't know if you know, because circle theorem, we know the two perpendicular bisector will meet in the center of circle. Okay, but anyway, so what do we need to find? We want to find the perpendicular bisector of PR. So we want to find a perpendicular bisector of PR, part A, okay, is a straight line. So PB, peanut butter, still a straight line. Did I say peanut butter or perpendicular bisector? Never mind, they're the same thing. So you would want to find use y minus y1 equals mx minus x1. What you need is, again, two things, a point and the gradient. Okay, so the point is the midpoint of PR. Okay, midpoint PR. And the gradient is a negative reciprocal of the gradient of PR. So this gives us guidance what to do next. First, work on the midpoint of PR. So midpoint of PR is 7 plus 3, half it. 6 plus 16, half it. And then, work it out. Minus 7, sorry, minus 7. Minus 7. Right. And you should get minus 2, 11. Okay. If you could see my mistake, well done to you. Another trap for you. I never make mistake, I told you. Next one. The MIP and the gradient. So the gradient is, we want to find the gradient of PR. So the gradient of PR is y2 minus y1 over x2 minus x1, which is 1. So the gradient of the perpendicular bisector is -1. Therefore, the equation of the perpendicular bisector of PR equals to y minus y1 equals m minus 1 x minus x1. So y minus 11 equals minus x. That minus minus becomes a plus. Minus a plus makes a minus. So y equals minus x plus 9. Just check my answer. Yes, that's the correct answer. Y equals minus x plus 9. Part B, find the center of a circle. Now, the perpendicular bisectors of the chords will always meet in a circle, meet in a center. So you know this, okay? You have to know this. I will say again, the perpendicular bisector of the chords will always meet at the center. So therefore, if I want to find the center of circle, all I have to do is to work out the simultaneous equation, the intersection point between the two perpendicular bisector. So part B. Part B. Okay, so I will say perpendicular bisectors of chords meet at center. So all we need to do is, so therefore we need to do simultaneous equation of y equals minus x plus 9 and y equals 2x. You can use a calculator for this. Well, if you could do it manually, which is not a difficult thing to do this one, thankfully for that. So 2x equals minus x plus 9, 3x equals 9, x equals 3. If x equals 3, y equals to 2 times 3, which is 6. Therefore, the center of circle is 3, 6. Okay, right. Part C. Find the equation of circle. To find the equation of circle, again, two things, the radius and the center of circle. We've got the center of circle already. All we need is a radius. Now we know this. Now we know the point is now 3, 6. So to find the equation of, the equation of circle, we need radius. So you can see radius is any point from the center of circle to circumference. So it could be, let's call this point C. So it's either CR, CP, or CQ, either one of them, up to you. Okay, so let's do that. So part C, to find the equation of circle, we need two things. Okay, center, which I already have, 3, 6, and the radius. And the radius is either CP, CQ, or CR, up to you, either one of them. Okay, so in here, I'm going to just use CQ. So CQ equals to square root of 3 minus 11 squared plus 6 minus, oops, that's a glitch, 6 minus 12 squared equals 10. When you put in a calculator, equals 10. So therefore, the equation of circle is x minus x1 plus y minus, x minus a squared plus y minus b squared equals radius squared, which is 100. Okay, and that's it. All right, so triangles in here, there's no triangles, but you have to, it's just all about problem solving in circles and straight lines. All right, so the best thing to do is if they give you some points and the circle is not given, try to draw one yourself to visualize what's happening in here. All right, so practice question 1. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Hey, yo, here's the answer. Okay, S, if you wonder if you have done the whole thing without using S, then you are correct. S is useless. Right. So to show PQI is a right angle triangle, use a gradient. So here's the answer. So you've shown the two gradient when you multiply each other equals -1. Then therefore PQ is perpendicular to QR. And therefore triangle PQR is a right angled triangle. Given that all 4 points lie on circle, that's bull because you don't need the S. Yes, even though you told me it's not a circle. What's the point? Nope. That's, useless. Find the equation of circle. To find the equation of circle, then therefore you would just, here, we know PQR is a right angle. Therefore, PR is a diameter. If it's diameter, then it's useful because to find this equation of circle, we need a center and we need a radius. The center is a midpoint of PR and the radius is half of PR, the length. So to find a midpoint of PR, add up the x coordinates, half it, add up the y coordinates, half it. To find the distance of PR, use the distance formula, and you get 10 root 5. Don't forget to half it to find the radius, 65 root 5. Then the equation of circle is x minus a squared. So it's whatever the x coordinate is, just do the opposite sign. So x plus 2 squared plus y minus 5 squared equals 5 root 5 squared. Don't forget to do the radius squared. You get 125. Okay, that's a very common mistake students usually make. Right. If you're happy with this, yes, exam practice. Okay, 4 marks, 8 marks, 8 marks. Yeah, you can do it. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the final answers for the exam questions. Okay, question A, to show random equation of circle. That's quite straightforward because they told you the center, they told you the radius. So x minus a squared plus y minus b squared equals radius squared. Okay, I'm not going to go through A. By the way, if you got all of them right, well done, move on. That's it. End of lesson for you. End of chapter 6. Well done. Good job. But if you don't, let's go through. Question B. Okay, so I'm not going through question A. Okay, question B. Show that the angle TMQ, so TMQ, so once you work out the angle here, is 61.68 degree. Okay, so what we can do is we can use the triangle TMP instead. TMP. Okay. So TMP because Q lies on MP. So TMQ is same as TMP really. But the best thing to do is P is because we know it's a right angle because a radius and a tangent makes a right angle. So if I want to work out that angle in here, theta, let's call this theta. What I need to know is some lengths. I know TM is a radius, 3. So what about MP? Well, MP, we can work out distance of MP. So the MP distance equal to square root. We've got the coordinates of M and P, so we can use the coordinates. What was that? Oh, looks like my square root is going for a roller coaster ride. Anyway, so I can do 6 minus 4 squared plus 12 minus 6 squared, which equals 2. Put in calculator, you should get 2 root 10. Therefore, this goes in here, 2 root 10. So if I want to work out the right angle triangle using theta, I can use cos SOHCAHTOA. So cos theta equals adjacent 3 over hypotenuse 2 root 10. So theta equals inverse cos of 3 over 2 root 10. Now, sometimes I might say arc cos. If you heard me saying arc cos, that's the same as cos inverse 1. Inverse of cos. That's the proper mathematical name of inverse of cos. Or arc sine, arc tan, they're the proper name. But you're not probably introduced that in GCSE. Anyway, so it's called arc sine, arc cos. So inverse cos, arc cos, whatever. Put in a calculator and finger cross, you should get 61.68 degree. Okay? Right, so theta equals 61.68 degree. Part C, 4 marks. The shaded region TPQ is bound by the straight lines TP, QP, and arc TQ, as shown in diagram. Find the shaded area. So to find the shaded area, I think the best way is to define a whole area of the whole triangle and remove the sector in there. Okay, so part C, okay, so the area of shaded area equals to the triangle minus the sector. Okay, so it's triangle minus sector. Okay, so triangle, let's do triangle. So triangle TMP equals, so half base times height, or half AB sine C, half A. So you can use this on the triangle, half A, B, sine C, sine the angle. So half A, B, sine C. I think that's the best way to do. Now, why can't you use base times height? You can, if you want to use base times height, you just have to work out TP as your height, and then that's your base. So base times height divided by 2, but that's extra work. We don't like to do extra work, don't we? So equals to, just like you want to finish this video as soon as possible, equals to 8.35. Okay, so that's the area of a triangle TMP. Sector. So to find the area of sector is the whole area of a circle times the theta over 360 times a fraction of a circle. So pi r squared, pi times 3 squared times this theta, which is 61.68 degree over 360. That's a fraction of a circle, how big that slice of a sector is. Put in a calculator, you get 4.84. Therefore, the shaded area will equals to 8.35 minus 4.84, which if you use the full value in the calculators, you should get 3.506. All right. And that's the end of the circle chapter.